Problem 2. Using radical expressions. Architecture. In the stained glass window design, the side of each small square is 5 inches. Find the perimeter of the window to the nearest tenth of an inch. Well, first consider the length of the diagonal of a square with side s is s times the square root of 2. That's derived from the Pythagorean theorem, and that the diagonal of a square can be thought of as forming two isosceles right triangles with side length s. In this case, the length of the diagonal of each 5-inch square is 5 times the square root of 2. The length of the window? Well, we can let L represent the length of the window, and that will be 3 times 5 times the square root of 2, counting 1, 2, 3 of those triangles, or half squares, for the length of the window. And that simplifies to 15 times the square root of 2. The width of the window, note we have 2 half squares, or isosceles triangles, along the width, and so it will be 2 times 5 times the square root of 2, and that's 10 times the square root of 2, to represent width, or in this case our variable w. Perimeter of a rectangle, recall, is 2 times the length plus 2 times the width, or 2L plus 2W. In our case, that will be 2 times 15 times the square root of 2, our length, plus 2 times 10 times the square root of 2, our width. This simplifies to 30 times the square root of 2 plus 20 times the square root of 2. We have a common index and a common radicand in these two terms, so we'll simplify this to 50 times the square root of 2, and then using a calculator to approximate, that's approximately 70.7. So we can state in our final answer, the perimeter of the window is about 70.7 inches. Your turn. Part A. Find the perimeter of the window if the side of each small square is 6 inches. And Part B, a reasoning item. Describe a different sequence of steps which you could use to compute the perimeter of the window other than the sequence shown in Problem 2.